Okay, so today we're going to keep going over limits by going over some different limit laws that we have. And so all of your limit laws are on a handout that was given out. So you can refer to that on your test and for today's assignment. It will be helpful because there's quite a few of them. So if I look at the first one, it says the limit as x approaches a of f of x plus g of x. This tells me that I can break this up into the limit of f of, as x approaches a of f of x plus the limit as x approaches a of g of x. Basically, I can distribute that limit to make the problem easier. And the same thing goes for subtraction. So I can distribute my limit and then subtract f of x minus g of x. If you're taking the limit as x approaches a of some constant times a function, you can just pull the constant out front and evaluate the constant at the end. If you are multiplying two functions, you can take the limits of each of those functions and then multiply those answers at the end. If you are dividing two functions, you can do the same thing. You can take each limit individually and then divide them as long as your denominator doesn't equal 0. For number 6, if you're taking some function to an exponent, you can evaluate the limit and then evaluate the exponent first. The limit of any constant is just that constant, is what number 7 says. And the limit of the function x is just equal to whatever you're evaluating. Same thing for the limit of x approaches a of x to some exponent. You're just going to plug in a. So you get a to that exponent. Same thing with a root function. The nth root of x is just actually the nth root of a. And lastly, if you're taking the limit of the nth root of a function, you can evaluate the limit and then take the root at the end. So any questions on our 11 limit laws? Okay. So I will give you guys a chance to copy down that graph. Okay, so if I look at example 1, A, I'm given the limit as x approaches negative 2 of f of x plus 5 times g of x. So I know that I can break that down into the limit as x approaches negative 2 of f of x plus 5 times the limit as x approaches negative 2 g of x. Because I can pull my constant out front and I can evaluate each of my limits individually. So if I look at negative where x is approaching negative 2 of f of x, my function in red, as x is approaching negative 2, I'm up where y is equal to 1. And if I look at where x is approaching negative 2 of g of x, I'm down at negative 1. So then 5 times negative 1 is negative 5, and 1 minus 5 gives me negative 4. I do the same thing for part B. I know that if I'm looking at functions that are being multiplied together, I can evaluate the limits separately and then multiply my solutions. So the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. So if I look at where x is approaching 1 at f of x, I'm up at 2. If I look at where x is approaching 1 of g of x, I'm down at negative 1. And 2 times negative 1 is negative 2. Then lastly, if I want to do the same thing for this fraction, I know that I can evaluate the top and the bottom separately, as long as the bottom doesn't equal 0. So as x approaches 2 of f of x, I'm up at somewhere close to 2 on my y-axis, and as x approaches 2 of g of x, then I am down at maybe like negative 0.25 maybe, because I'm not quite at 0. I'm in between 0 and 1. So then if I evaluate that, 2 divided by negative 0.25 gives me negative 8. Does that make sense? Yes? Yes? Okay. So we're going to do the same thing for functions a and b. So if I'm given a limit as x approaches 5 of 2x squared minus 3x plus 4, I know that I can evaluate that limit for each of my pieces. So the limit as x approaches 5 of 2x squared minus the limit as x approaches 5 of 3x plus the limit as x approaches 5 of 4. Okay, and the easiest way to evaluate a limit is to use direct substitution, if possible. So I'm going to directly substitute that 5 in for x. So I get 2 times 5 squared minus, if I plug in 5, I get 3 times 5. And what do I know about the limit of a constant function? I think it's like rule number 7. It's the same. So this just the limit as x approaches 5 of 4 is just 4. So then if I evaluate 5 squared is 25, and 25 times 2 is 50. 3 times 5 is 15. And what's 50 minus 15 plus 4? 39. Alright, if I do the same thing for b, the limit as x approaches negative 2 of x cubed plus 2x squared minus 1 divided by 5 minus 3x. I know that I can evaluate that limit for each of the pieces. So the limit as x approaches negative 2 of x cubed plus limit as x approaches negative 2 of 2x squared minus the limit as x approaches negative 2 of 1 divided by the limit as x approaches negative 2 of 5 minus the limit as x approaches negative 2 of 3x. Basically just distributed my limit. And then once we do that, we can use direct substitution to solve. So I get negative 2 cubed plus 2 times negative 2 squared. What's the limit of a constant? It just stays the constant, so that just would stay the minus 1. Same thing here with this limit of the constant 5 would just, that was a terrible noise, stay 5. And if I plug in negative 2 here, 3 times negative 2. Alright, so what's negative 2 cubed? Negative 8. Okay, and negative 2 squared is 4. 4 times 2 is 8. So I get plus 8 minus 1. And negative 3 times negative 2 is 6. Alright, so what's negative 8 plus 8 minus 1? Negative 1. And 5 plus 6 is 11. So my limit would be negative 1 over 11. Okay, so you guys are just going to work through breaking limits into pieces of their parts. So page 69, 1 through 9, and 11 through 20.